In this tutorial, I'm going to demonstrate that we are now at a place where computers can see. We're going to show you how to take a Raspberry Pi with a generic camera and create an object detection algorithm to detect any arbitrary object that we want from either a video or a picture. Okay, so this is our Raspberry Pi prototype. This is just a generic camera that you can get on Amazon, and inside this cardboard box, it's just housing our Raspberry Pi Model B+, which is going to have all the basic ports. And essentially what we're going to do is power this up and do a stream of the video, and we're going to analyze the frames in that video and run a machine learning algorithm, computer vision algorithm, to detect if the guitar is in the frame or not, and we'll return a binary yes or no with a corresponding confidence probability. So this is my guitar, and we will use this for the demo. So basically, when the camera is taking pictures, it should be able to detect if there is a guitar, specifically this guitar, if this guitar is in the frame. Okay, so one of the first things I'm going to want to do is actually take some pictures of the guitar, which we're going to use as training data and also validation data. Now, we don't need a lot because the model that we're using is really good and really efficient, but we should have a couple. So I'm just going to set up the guitar like that, take out my iPhone, and grab a couple pictures. Okay, so the first thing we want to do is create the model itself. So this is going to be a classifier that can take a image as an input vector and output a probability that a particular object is contained within that image. So this is a fairly common use case. We actually have a Docker container queued up to tackle this exact use case. All we have to do is organize the training data and provision that environment. So we're going to go through that right now. So I'm going to open up my terminal here, and again, like I said, we have a Docker container that is that specializes in this exact functionality here. So if I go and list my Docker images, there's one called TensorFlow, and it's for the Macgyver technology username. So that's going to be the container that we use. So to stand up an instance of that image as a container, we're just going to do docker run -it-d, which means detach. So it'll be running in the background. We can hop in and hop out and just keep it up there. We're going to run that. And now if we do list containers, we can see the container, and it's been up, started 5 seconds ago, up for 4 seconds. And we can log right into that container. So we'll do docker exec -it. We'll supply the container ID, and then we'll run bash. And now you can see it says root at container ID, and this is our workspace here. So this container has TensorFlow installed, and it also has the Inception v3 image classification model, which we're going to use as the foundation for our classifier. So basically, we're using transfer learning, which is we are going to leverage an existing computer vision classification model and train the final layers to detect a novel object, but we're going to be able to glean kind of a lot of the work that had been done previously. There are other similar models, VGG, ImageNet, but I find Inception v3 to be very easy to use and ends up rendering with high accuracy probabilities. So the next step here is to create a directory of images containing guitars, which is the object that we want to be able to recognize. And then we'll create another directory containing images of kind of random objects, which will be used as a control group. And then the classifier will take an image and either lump it into kind of random classification or the guitar classification if that's what's detected. So there's a bunch of different ways to get image training data. I have kind of a hacky workaround where I use a Chrome extension and get the images from Google search. So as far as kind of rapid prototypes are concerned, it works pretty well. Okay, so I'm going to search for the exact brand of guitar that I have, because the more specific you get with it, the better the model's going to perform. So again, I'm in Google Images. I'm just scrolling down so that these lazy load. And then I'm going to come over to my extensions. I'm going to select the extension in question here. I'm going to select Dig Images. And essentially it's going to try to find all the images. And all the images. And you just have to curate this list. So I'm going to click Select All. I'm going to remove these because they're not quite right. And the rest of these look pretty good, actually. So if you adjust the dimensions here, it'll actually include more of the images. So let me just go through and curate this list real quick. So that's not something I want it to be trained on. The rest of these look pretty good. Let's see here. So these images aren't right. Okay, so that's good. This is our training data. It's not a lot, but the approach we're using, you actually don't need a lot. And again, we're not going for like the most accurate. We're just going for, we should get higher than 90%, which is pretty good. But if we wanted to, get that last couple percent, we would probably just get a lot more training data. So let's go to create new site folder and save. So I'm going to call this guitar, and it's just going to save it to my hard drive here. And again, I said it's kind of hacky. It is, so you kind of have to keep pressing enter. Okay, so now we have a directory with a bunch of images of guitars. I think this will work pretty well. Okay, so we do need to create another directory, kind of a control directory. So if we just search kind of random picture, these are really odd, but it should actually still work. So I'm just going to get some random images. These could be anything. And we're going to use these as kind of a control group. Okay, so now we have another directory with a bunch of random images in it. So this should be sufficient. So I'm just going to organize these directories real quick, and then we're going to copy them into our Docker container and then run the training. So again, this terminal has, this is me inside the Docker container. I'm going to open another window, and I'm just going to take those local directories and move them over to the Docker container. Okay, so we can see the two directories, guitar and then random control. So let me go into guitar, and they name the subdirectory 2040, which I don't like, so I'm going to rename that to guitar. And then I'm going to copy this directory into the Docker container. So let's actually make a base folder here. So let's make a folder called images. And what I'll do is I'll copy this directory into the images. So Docker CP, I'm copying the guitar directory, and I'm copying it to the container into the images subdirectory. So now if I go into images, we have guitar. So now let's do the same thing for random control. Oop. So I'm just going to rename this to random, and then I'm going to do Docker CP random, and then we're also going to copy that to images. So you can copy from your local host to the Docker container using that CP command. It's pretty useful. Okay, now if I list, okay, I see guitar and I see random, so that's awesome. So I'm going to do one more thing, which is I'm going to create a directory called test, so that we can test some novel data against the model and just make sure that it's performing pretty well. And in this case, we already have a directory called test. In this case, we're going to use those images that I took with my camera. So let me send those over to my computer right now. Okay, those are the images that I just took. And the only thing I'm not sure about is the file extension .heic. I think we're going to have to convert those, so let's just open this up real quick. Okay, so those are just some test images that we can run against the model and make sure that it's performing as we expect. So let's copy those over as well. Okay, so I'm copying these two images into the Docker container. So if I go to test -image, sweet, guitar 1, guitar 2. Okay, so we want to run the retraining, so that command is in commands.txt, and we want this command here, which is to execute a Python script with a bunch of arguments here. And the image directory argument is the only one that we need to change. We need to change that to images. Yeah, images. So it said training images, but we actually want images. And it's going to automatically pick up these two labels, and everything in this directory it's going to associate with the label guitar, and everything in this directory is going to associate with the label random, and that'll just serve as our control group. It's going to output a probability for each of these classes. So we're just going to run this training, and it shouldn't take more than 5 minutes or so. Okay, it looks like the training is done, so that's cool. So what we're going to do is we're going to now run a prediction against the model and just ensure that these probabilities are as we expect. So again, if we go to our directory test image, we have two images of guitars that we'll use. So the prediction command should be listed in commands.txt. It's this guy right here. Okay, so let's just change the argument here to test image guitar1.jpg. So it's going to spit out two probabilities, and I expect the probability associated with guitar to be drastically higher on this one here. So let's give it a go. Not too shabby. So 0.9999, so it's just very, very accurate. Let's give it guitar 2. Yeah, also very accurate. So I think this is going to perform really well. So we can keep the model the way it is now, and we'll use this as the basis for our image classifier. Okay, so there's different ways that we could deploy this model to the Raspberry Pi. It is currently in a Docker container. I just tried moving that Docker container to the Raspberry Pi device, and I was having a little bit of trouble. Probably has to do with the fact that running TensorFlow in a Docker container on a Raspberry Pi is a little CPU/memory intensive. So I'm going to opt to do it through a different method. So what I'm thinking is, instead of deploying the model to the edge on the Raspberry Pi, we can keep the model in the cloud, and the Raspberry Pi will just take the images and send that data to the cloud to process, and then return the response. So we don't have to be constricted by the system specifications on the Raspberry Pi. So for hosting this model in the cloud, we can use the tool that I built called Macgyver, and I will show you how to do that. It's fairly straightforward. We also use Docker containers, so it's going to be compatible. Okay, so this is my Macgyver account, and I'm just going to come over and create a new program. So let's just call this guitar detection, because that's essentially what this program is doing. And so there's a bunch of different parameters here, but basically the way it works is you take the Docker container that you've used for your model development, and you just push that whole container to the Macgyver system. Now, for everything to work, you have to have a folder called Macgyver. You have to have an executable called main. It can be any programming runtime, Node, Python, Bash, etc. And in our case, what main is going to be is a Python script. And basically, we're setting up an API here where a user is going to pass a reference to an image, and then we're going to process the image and return a response. So we store the user's API data into a folder called data.json. So the test data would look something like this. So a user posts this to the API, and then we'll evaluate this image against the machine learning model and print out the response. So I have a demo example of like a guitar here. So if I were to go Google that or put that in the URL bar, it would turn up a picture of a PRS guitar. So basically, when a user hits this API, this data will be written into data.json, and the API will run the main file, and I'll run that file given the runtime provided. So in this case it's Python, but it could be any runtime you decide. So if I run this, it's going to take this image, download it, and evaluate that against the model and return the response. So we can see here it did peg this image as being having a guitar in it. So that's exactly what we expect. So all we have to do now is take that container, push it to Docker Hub, and then sync that to Macgyver. So I am going to exit this container because it seems like everything's working properly. And I'll just list out my containers here. So let's go ahead and take this container and just give it a new name. So we're going to commit that container to some new image. Let's call it guitar detection, and then we have to version it with a tag, so let's give it 1. So Macgyver technology, guitar. Okay, so that looks good. So we're taking that container, we're committing it to a new image, and then we're going to just take that image and push that into Docker Hub. So now we're pushing this up into the cloud, and the registry we're using in this example is Docker Hub. There are other registries, Google, etc. But the Macgyver tool is configured to work currently with Docker Hub. So I'm just waiting for this to load. And we can actually come back over to our program here. So we're going to provide a runtime, and in this case it's going to be Python. And then the image name is going to be what we just defined right here. And it's going to say pull Docker image, and it's going to pull from Docker Hub. Now we don't want to do that yet because we want to wait for this to push fully. And then something else we could do if we want is we could show this as the example input, so users know what data they need to provide. And then we could actually show this as an example of how the API is going to respond. Okay, and again, we're just waiting for this to finish pushing. Okay, so our local image is now completed being pushed to Docker Hub. So now we can fill this out, and again it's going to be Python, and let's just provide the image name, and it's going to expect the class, the version / tag to be 1, and that's exactly what we have. So let's go ahead and pull this. And sometimes it takes a little bit of time for it to sync to the platform. Okay, it looks like it may have synced. Let's add a little description here. This API takes a reference to an image as an input and returns the probability that a guitar is detected within that image. Okay, and then we do need to give it a price. Just give it a super low price for now. All APIs are free for the first 1,000 requests per hour, so they're basically free unless you're using them at high scale. Okay, so all we need to do now is go ahead and publish this, and that will make it publicly available. So now if I come over to Model Hub, I should see my new model. Okay, here it is, guitar detection. And we should be able to just run an example in the browser, and if it's working, we should get a response. Great. So we just got a response, and again, this is the data that we posted. So let's go ahead and actually try something a little bit different. Let's say acoustic guitar. So it hasn't been trained on this kind of guitar, but it should still pick up the general contour. But I'm thinking it might not be as high a percentage of accuracy, but let's give it a shot here. So let me just make sure. Okay, so what we can do is we can literally take the URL for this image, and we can supply that here, and we'll get a new prediction. Yep, new prediction, still super high, 99%. So this is looking good. So now we have our model deployed onto the cloud, and all we need to do now is the Raspberry Pi is just going to interface with this API. I mean, it still needs to take the picture and it needs to stand up the picture, and then it just needs to make an API request. So we'll probably use the Python driver, something like this, but we'll use one of these approaches, and we'll just run the model in the cloud, and that should make things easier. So we'll move on over to the Raspberry Pi itself. Okay, so we have the Raspberry Pi set up, and I essentially wrote a script where every couple seconds it's going to take a picture. It's going to upload that picture to a Google Cloud storage bucket, and then it's going to run the model that we created, the Macgyver model, against that image. A response is going to come back, and if a guitar is detected in the image, one audio clip is going to play, and if a guitar is not detected, another audio clip is going to play, and that's going to be apparent when I run this script. So I'm just going to play a little guitar in the background, and I'm going to walk in and out of the frame, and I'm hoping that the Raspberry Pi will be able to pick up on that. So right here, I just have a terminal open, and I'm inside my Raspberry Pi. I'm connected via SSH. So I'm just going to run my script. So the script is called guitar.js, and it is a node.js script. So you can see there's a picture that's coming from the Raspberry Pi. There is no guitar in that picture. Show me your guitar. Show me your guitar. So now I'm going to go in the frame. That is a beautiful guitar. See, just detected the guitar. That is a beautiful guitar. Show me your guitar. That is a beautiful guitar. That is a beautiful guitar. So it's detecting with each frame whether there's a guitar in the frame or not, and really it's that easy. And we created this model. We're deploying it on a Raspberry Pi. So you know, we can pick any arbitrary object, and we can now actually detect if that object is within sight. So this is pretty powerful. And I hope you enjoyed that tutorial. Thanks for watching.